Ladies and gentlemen, this is the 7th lecture in the module of Lean Six Sigma, Measure Phase. During the lecture, the following topics will be covered: spaghetti diagrams, value stream mapping. Spaghetti diagrams are diagrams that depict the physical flow of work or material in a process. It shows the material flow in a process, and illustrate the wastes of transportation and motion that should be eliminated in producing a more lean operation. It is used to improve the physical layout of a workspace, office, factory, warehouse, or a work form. In lean operations, it's useful to show the current state of the layout, before, and after, and the suggested improvement. Example for spaghetti workflow diagrams. The sample will be moved from 1 to 2, then to 3, and so on. Consider the product machine incident matrix shown, where 7 parts are being fabricated by 9 machines. The 9 machines are CNC lathe, H milling, V milling, surface grinder, turret lathe, sawing machine, shaper, shearing machine, and folding machine. We can see the flows of the 7 parts. Please notice how the flows are very complicated, and intersection. One way to reduce the waste of transportation is to convert the previous functional layout into another layout. Please suggest the suitable layout to reduce the waste of the transportation. Please pause the lecture and solve the exercise. One way to reduce the waste of transportation is to convert the previous functional layout into a cell layout. A production flow analysis (PFA) approach is used through a sort of clustering algorithm. The result is shown. Now, the work layout has been divided to 3 cells. Each cell contains 3 machines. The flows now are much simple and short, and no intersection. Please note the reduction in the waste of transportation, before and after. Value stream maps is used to capture all key flows of work, information, materials, in a process, and important process metrics. More complicated to construct than other flowcharts, but much more useful for identifying and quantifying waste, especially in time and costs. The value stream map presents a picture of the value stream, from the product's viewpoint. It is not a flowchart of what people do, but what actually happens to the product. It is necessary to collect process data to construct the value stream map. 1. Create an as-is version at the project, tactical, level and define phase, and measure phase, to identify and visualize the improvement opportunities. 2. Create a future version, should be, and improve or control. To create value stream maps, we will follow the steps. 1. Determine what product, service, or family you will map. If there are multiple products or services, choose one that meets as many of these criteria as possible. Has a common flow, all products or services in the family use essentially the same steps. Has high volume and cost. Meets industry or other segmentation criteria important to the company. Has the biggest impact on customers or the customer segment of choice. 2. Draw the process flow. Review process mapping symbols. Begin at the end of the process with what's delivered to the customer and work upstream. Identify the main activities. Place the activities in sequence on the map. Example of the value stream map symbols using by Sigma Excel. 3. Add the material flow. Show the movement of all material. Group together material with the same flow. Map all sub-processes. Include any incoming inspection, and material and process testing activities. Add suppliers at beginning of process. 4. Add the information flow. Map the information flow between activities. For manufacturing areas, document the production orders associated with the parts through the process. Document the scheduling system and tracking of the parts as they move through the process. Document how the process communicates with the customer and supplier. Document how information is gathered, electronic, manual, go-look, etc. 5. Collect process data and connect it to the boxes on the chart. Walk the process to observe reality. Determine takt time. For each step, gather the following data. Trigger what starts the step, and cycle time. Setup time, changeover time, and processing time or unit. Percent defective and or scrap rate. Number of people, workers. Downtime percent includes any time that people cannot reach full productivity, because machines, computers, materials, information, etc., is not available when needed. WIP downstream and upstream, cost of links to IT, warehouses. Batch size, number of pieces. Include delays, queue times, processing, value add time, setup time, batch size, etc. To access the takt time calculator. In Sigma Excel, click Sigma Excel, then Templates and Calculators, then Lean, then click Takt Time Calculator. The template gives the following default example. These values, sorted alphabetically, are manually entered on the shape. Percent of availability, the percentage of time operators are available for this step in the process. Duration of changeover time, the time taken to change from producing one type of product to another type of product, assumed to be the average of accumulated changeover time per shift. Percentage of defect, the percentage of flawed products discarded at a step, used to calculate timeline data type, rolled throughput yield. Percent of defective deliveries, the percentage of products damaged in the process of being delivered at a step. Distance traveled, the physical distance the product travels between, or within a process step, supports both imperial and metric distance units. Inventory amount, the number of pieces between or at a process step, time is calculated as per VSM properties. Duration of inventory time, combined with inventory amount on the timeline, if inventory amount is also entered. Duration of non-value added time, the time in a process step that a customer is not willing to pay for, usually defined for steps that do work, as inventory time, or transport time typically record the time it takes to move materials. Number of operators, the number of workers per shift, working in parallel at a step, enter numbers greater than 0. An empty field calculates as 1. If value is entered, then a visual indicator and number show on the shape. Any number larger than 1 reduces production time, and increases the capacity of the step, because the notion of parallel identical operators, stations, or equipment is introduced. Processing time, total cycle time, remains unchanged, as each operator, or operation still takes the same amount of time on each piece of work. so changing the number of operators will affect the work balancing graph, production time, but will not affect the lead time, processing time, on the timeline. Duration of processing time, the time for one product to move through a process step. This is sometimes referred to as total cycle time. When processing time is called cycle time, it can be confused with production time, the time between products leaving a process step. They evaluate to the same if you have one full-time operator, no defects, and 100% availability. Duration of transport time, time taken to move materials between steps. Percent of uptime, the percentage of time needed equipment is available for the step in the process. Duration of value-add time, time in a process step that a customer is willing to pay for. These values can be calculated for you, or you can override the automatic calculation. Substitute the percentage value with the equivalent decimal value. For example, 100% is 1.0, and 5% is 0.05. Available time, default is seconds, based on diagram settings. Takt time, default is seconds, it is also based on diagram settings, calculated as available time divided by customer demand. Number of shifts, based on diagram settings, this value can be overridden to affect capacity at a process step. Production time, default is seconds, it is processing time divided by 100% minus defect percent, times percent of operators times availability. Number of capacity, per day, it is equal to available time, minus changeover time, times number of shifts, times percentage of uptime, divided by production time. These data types are used to calculate data that appears in the timeline. Raw materials, work in process, and finished goods are automatically calculated, based on value-add time. Percent of process cycle efficiency, value-add divided by total time, times 100. Percent of rolled throughput yield, product of yield at each step. iGraphics measures defects through defect percent. Yield is based on 100% minus defect percent. Raw materials time, time before valuable work is started. Work in process time, time spent from first valuable step to last valuable step. Includes all time that passes from the first step with value-add time to the last step with value-add time. Time before the first whip shape is deemed to be raw materials, and time after the last whip step is deemed to be finished goods. The timeline displays value-added time, time a customer is willing to pay for, and lead time, the amount of time it takes a piece to move through the process, using lean data elements built into the diagram. This facilitates analysis of the material flow of the value stream. Based on data entered on the shapes, value-added time displays on the lower segments of the timeline, and overall lead time, which includes value-added and non-value-added time, the time a customer does not want to pay for, displays on the upper segments. Inventory shapes typically cause inventory time on the timeline, based on the time necessary to process all sitting inventory. This inventory time can be entered directly on the shape, or, if inventory count is entered, the inventory time will be calculated based on the inventory calculation setting. Lead time is equal to inventory time plus processing time. Processing time is equal to value-added time plus non-value-added time. The summary box on the timeline shows the total lead time and value-added time of the process, as well as optionally showing the process cycle efficiency percent, which is value-added time divided by total lead time. The distance line helps you analyze the waste, generated by unnecessary movement of work items. The three value stream mapping sections are information flows, material flows, lead time ladder. Thank you, and see you in the next lecture of the measure phase. The lecture will cover the implementation of the value stream mapping using iGraphX and Minitab.